All right, so we are in the last section of Chapter 5. And as I mentioned at the tail end of the previous video, that we want to have some techniques for dealing with the inverse trig functions. We want to be able to do the same types of calculus. We want to integrate. We want to take the derivatives. We have studied differentiation. We now want to begin integrating various inverse trig functions. So, as always, as my professor at Mason once told me, that derivatives are fairly straightforward. It is kind of like, here's the question, what's the answer? Whereas integration is more of a puzzle. It's kind of like, here's the answer, what is the question? And what the game that we're going to be playing, so let me kind of draw attention to the three integration formulas that we're going to be dealing with. And there's a little bit of matching, like a game of matching that you have to do. So, for example, taking a look at each of these integrals, at first glance, it's hard to know, well, wait a minute, are we dealing with an arcsine, an arcsecant, an arctangent? So we kind of have to play a matching game, right? So for example, part A, does that seem to look more like, the formulas in 1, 2, or 3? Well, you'll get better at it, but let's kind of start to play that game. So first off, let's take a look at each of these formulas, and let's take note of the notation of A and the notation of U and what they mean. So in this case, let's start with A. So A is going to be some constant greater than 0, right? So A is the number, it's the constant, whereas the U is the function. It's some differentiable function. So let's kind of look at part A, and we'll both try to match it with one of the three formulas above, while at the same time we'll try to figure out, well, what would A be in this case? What would U be in this case? Well, notice that, for example, part A, we have the constant minus the variable, the variable, if you will. So in that case, notice that arctangent has a sum, so that doesn't, and there's no square root, right? So it definitely can't be arctangent because this both has a square root, and we're not adding. Arcsecant doesn't look like it matches either because that arcsecant has u times the square root of u squared minus a squared, and we don't have another u out front here. So this looks like it matches arcsine fairly well. Okay, so now that we know which integration formula we're going to be using, let's go ahead and define some things. Well, let's start with A. What would A be? So notice that the square root of A squared. So there's some number, some constant out there that you can square, but to get 4. Well, that's fairly straightforward, right? So A squared for this case, where we have an A squared here, we have a 4 here. So if A squared equals 4, therefore A must equal what? Must equal 2. All right, that makes perfect sense. Well, what about we have minus u squared, but instead of u squared, we have x squared? Well, if u squared In our example, we have an x squared. Then what must u equal? U must equal x. Now, let me point out some silly mistakes that I've seen over the years of teaching this course. So some students will notice that the u squared is equal to x squared, but I'll have a lot of students who will write u squared is equal to negative x squared, because they see this minus symbol, this negative symbol here. So they set u squared to be equal to negative x squared. Well, that makes no sense, but you also have to make sure you understand that this minus symbol is part of your integration formula. So now we have a defined, we have u defined. Let's go ahead and write out our result, right? So in other words, if your integration problem looks like this, then we just get to jump right, like a table, right? We get to jump right to the format of the answer. And the format of the answer should be arc sine of u over a plus c. And the only thing that we need to do is we need to plug 2 in for u, and we need to plug x in for, no, I think I drew those in the wrong spot. 2 in for a, we need to plug x in for u. So let's finish that up. So arc sine of x over 2 plus c. Not bad, right? Not that bad. All right, so for C, what I'm going to do for problem C is I'm actually going to do that for you, or I'm going to give you that result on another page, since I don't have a lot of space here. So let's go ahead and box this in, and we'll begin our work on part B. Okay, so the game is the same. So you have to imagine, so you're asked to integrate the following, and somehow something is going to have to trigger this muscle memory to say that, wait a minute, this looks like a inverse formula, right? A trig inverse formula. And now let's just make sure we can choose the right formula as well. So clearly we have taking a look at the denominator, see how there's no square root. So that automatically says that, well, this is not an arcsine problem. This is not an arcsecant problem because they have square roots. This must be an arctan problem. So right now we know the format. So looking at arctan, so in this case, it's a squared plus u squared. So we have an a squared where there should be a 2, or my apologies, we have a 2 where there would be an a squared. We have a 9x squared where there would be a u squared. So let's use that to our advantage. So if a squared is equal to 2, then a must equal what? Well, think about it. What could you square? What number could you square to get 2? Well, if you square the square root of 2, you would get 2, right? If you square the square root of 2, you would get 2. So a must be the square root of 2. Now, let's take a look at u squared. So in our case, u squared, we have 9x squared. So we should be able to use that information to figure out what u is. Well, so there's some number out there that if you square it, you get 9x squared. Well, are you with me that 3x would work? 3x works, right? Makes sense? Square 3x, 3 squared is 9, x squared is x squared. So with that, all right, so we now have a, we now have u. So let's go ahead and let's see if we can make this work. So I'm gonna backtrack over here as well in just a second, but let's go ahead and plug everything into our formula. So at this stage, we would have the integral of, so right now we have dx, and then this would be the square root of 2 squared plus 3x squared. And now we need to make sure that all the parts are in place in order to integrate, right? So as soon as I plug a in for the square root of 2, right? As soon as I plug in a here, and as soon as I plug in u here, that what I would have would match perfectly here, except for the fact that we have a dx when we need a du. So if u is defined to be 3x, then du, right, the derivative of u with respect to x would just be 3 dx. Now, does it make sense that what I want to do is I want to substitute? I want this to become du, right? And I can do that, but I need to have 3 dx. Now I have the dx, but I don't have the 3. So that's not a problem. I can, if I put I can multiply by 3 as long as I divide by 3. So this little manipulation is what's going to have to happen in order to integrate this. So I can place a 3 here as long as I divide by 3 here. All right, I know that's a little bit cluttered, but now I can look. Now I can actually substitute du here. I can substitute a here. I can substitute u here, and then it matches perfectly with our integration formula. So if it matches perfectly, then we can just jump right to it and use our formula. So it's going to equal 1 over a arc tan of u over a plus c. So that is the generic template. We just need to park everything in the right spot. So let's put the square root of 2 here for a, and let's put 3x here for u, and then all is said and done. So 1, and let's not forget our 1/3, right? So let me go ahead and write that. So 1/3 distributed into 1 over the square root of 2 arc tan of what? Of 3x over the square root of 2 plus c. All right, so beautiful. So we're done. So part D, let me go ahead, I'm sorry, part C, let me go ahead and grab this. And for just the sake of time, I'm going to go ahead and I've already worked out part C for you here. So if you have to, you can pause the video. You can pause the video, take notes. You can also, if you have the time, you could pause the video, try part C, see if you can get it to work. And if you can, wonderful. But if not, here is a resource that you can go back and double check your work. But moving on. So what I've done here is I took theorem 517, those integrals that we had in the previous page. I just brought it here so we could have it readily available. And now here comes. Let me just see if I can lay out the hard part for you. So the hard part for you is going to be when you're taking a test and you come across an integral like this, and you're going to have to start to develop like a playbook, like a tool set where you start to think, okay, well, wait a minute, can I use the substitution method? Can I use a formula? Can I, you have somehow you're going to have a process of elimination so that eventually you get to a part where you say, okay, well, wait a minute, that looks like it might be one of the integral formulas for trigonometric functions. Okay, so we don't really have to do that. We don't have to do that much in this section because we know that this section is devoted to these three integral formulas, right? So I'm just more or less just, if you don't mind, think ahead when you have this question as well as 9 other questions or 10 other questions on a test, and somehow you have to be able to associate which formula to use here. Well, let's see if we can figure out which of those formulas works. Well, upon first look, let's go ahead and we definitely can rule out arctangent, right? Because we have a square root. You might think, so at that point you're thinking, well, it's either arcsine or it's arcsecant. Please be careful not to make be too hasty to decide which one. Let's start with trying to define some things, right? So in this case, what would A be defined as? Well, remember A is the constant. So in this, looking here, our constant is 1. So if A squared is equal to 1, then A must equal 1. Now, do you see that for arcsine, it's constant minus variable? But that's not what we have, right? It's constant minus function of x. But we have function of x minus constant. So we actually, look at arcsecant. Arcsecant is function of x minus constant. So this is actually going to be an arcsecant problem. But let's stay with how we're trying to define things, right? So if A squared is 1, then A is equal to 1. Now let's go to U squared. Now where we have e to the 2x. So we need to now be able to figure out, well, then if e squared is e to the 2x, then if u squared is e to the 2x, then what is u? I have a feeling that I've said that wrong 2 times in a row. If u squared is e to the 2x, what is u? I feel like I said that right that time. Okay, well, look, something squared must equal e to the 2x. Well, e to the x times e to the x is equal to e to the 2x, right? So, in other words, u is just e to the x. All right, now, since we're here, so if u is e to the x, what is du? Well, remember, it's pretty easy. The derivative of e to the x is just e to the x. So So du is e to the x dx. Okay. What's going on here? What are we missing? Let's see if we can spot what we're missing here. All right, so this is our u squared, this is our a squared. But do you see how we want to be able to we want to be able to substitute in for dx, right? So if du is equal to e to the x dx, let's just solve. That would mean that dx is equal to d to the u over e to the x, right? Look, if you want to get dx by itself, divide by e to the x here, divide by e to the x here. All right, now I know what dx is defined as. Dx is defined as du over e to the x. And what is e to the x? Right, e to the x is just u. So du over u. Okay. So if we start subbing, right, let's start subbing into this formula. Let's see what we got. So now I would have the integral of, well, instead of having a dx, I want du over u. So du over u. If there's someone right now thinking, well, why doesn't my professor keep that e to the x here? Just think about that question. Right? If you're going to integrate with respect to u, then everything inside the integrand has to be in terms of u. So if I put an e to the x here, then I have x's in my integrand, I have u's in my integrand. I need everything in the integrand to be the same variable. Okay, well, I would also have the square root of e to the 2x, so that is u squared minus a squared, and here it is. So if the whole time, if you have been thinking, Professor, how are we going to use arc secant? I don't see how there's a u here. I don't see anything attached to the radical. Well, as soon as you manipulate this, all right, you can rewrite that as the integral of du over u. Now, remember, I'm going to write it down here. So this is the way you would translate this, right? This is du over u divided by, right? The divided by is this division symbol here. Divided by what? Divided by the square root of u squared minus a squared. Now, if it helps you, you can think about that as over 1. And what do you when you divide fractions, you flip them, you multiply them, right? So that would have to flip. Oh, my apologies. Where was I? So let's go ahead and let's get rid of this division bar, and we will flip this and multiply it. So that's going to be times what? Times 1 over the square root of u squared minus a squared. And there it is. Now this matches perfectly. So you got du, and then you have u, oh, my apologies, let me make sure you have du, and then you have u times the square root of u squared minus a squared. U times the square root of u squared minus a squared. So do you see the game that we're playing, right? So I agree with you, it's not easy. But this type of manipulation allows us to jump right to the result, right? So in the result, use of this arc secant is 1 over a arc secant of the absolute value of u over a plus c. And so we get to jump right to that integration formula. Let's just make sure that we plug in 1 for a. Let's make sure we plug in e to the x for u. And then we're done. So this is equal to, well, I'll tell you what I'll do. There's no need to have, this is me plugging in for a. 1 over 1 arc secant absolute value of u, which is e to the x, divided by a, and a is again just 1, plus c. All right, I agree with you. There's no need to have those ones, right? So 1 divided by 1 is just 1. So this is just arc secant e to the x divided by 1 is just the absolute value of e to the x. There's no need to even have the absolute value because that cannot be negative. And we're done. All right, I will... let's go ahead and take a break. This is a lot of information. You will have to practice. I know. My apologies that you picked a tough major, right? You picked a major that someone's going to pay you a lot of money because you have the degree, and yeah, I understand this is not easy, and if you don't get some practice in, right, you're going to, how many of you could see yourself looking at this integral and thinking, hey, that looks like it matches arc sine, and that leads you astray, right? So you got to get some reps in, you got to get some practice in so you can get better. But we're gonna go ahead and take a break, and I'll see you when we get back.